So in problem 24, what are you going to be left with? Yes. So algebraically, I'm going to show you what's happening. So again, as long as this base down here and then whatever I'm taking the log of are the same, then they end up canceling each other out. Really, it gives you just 1 is what that means. It just gives you 1, and you're just left with 5. So I'm going to talk about this. I'm going to go back to the original problem because some of you are like, but why? Why does that work? Completely valid question. I'm going to go back to the original problem. Log base a of a to the 5th. We don't know what that's equivalent to. We know it, well, we've done our work and we've figured out it's 5. The question is why. So we're going to pretend like we don't know that. And I'm going to say that it's equal to x. Just so that I have it equal to something, because then I can actually do some manipulation and I can solve things. So one of the things I told you last week was that if you had the log, and we wrote this on our notes at the very top of our notes. If you have the log base b of a equals x, that is the exact same thing as saying b to the x power equals a. That those two forms are interchangeable. So we're going to apply that process. We're going to change the way this is written based on that information. So in that case, what is b in our problem that we're working with? 8. So we have 8. Okay, to the x power. Well, what's x in our problem? It's just x, actually. So to the x power equals, okay, what is a in our problem? 8 to the 5th power. It's not just 8, it's 8 to the 5th power. That whole thing is a. So I really have the problem is 8 to the x power equals 8 to the 5th power. Well, use common sense. If this is what I have written, what does x have to equal? That's the only way that problem's equivalent. If x equaled anything else, that wouldn't make sense. So that's why our answer is 5. Okay, so we're going to apply that process to several other problems. So look at problem 21. What am I going to be left with? Notice that my base is 5, and I have a 5. So what's my answer going to end up being to this problem? X minus 5. When it all simplifies out, it's just x minus 5. Could you rewrite that? Like, could you move this exponent down to the coefficient first? Yes, and that's fine. Some of you need to do that because it makes more sense to you to see this as x minus 5 times the log base 5 of 5 and then think, oh, all this is going to cancel. It doesn't really cancel so much as like it gives you 1, and anything times 1 is whatever you had before. Okay? All right, so what about question 25? Can we apply that process to question 25? I have to simplify the 9. How? Can I just divide it by 3? We'll come back to that. Hold on. What can I do with that 4? Let's do some changing things first. Okay, the 4 can become my coefficient. So 4 times the log base 3 of 9. I do like the idea of simplifying the 9, but I need to simplify it. Like, I need to write it so that, like, what needs to happen is that since this is 3, I need this to be 3 as well, basically. I can't just, like, arbitrarily square root it, but I can rewrite 9 as 3 squared. I can do that. Because isn't 3 squared the same thing as 9? Okay. So what y'all have to keep in mind, is there an equal sign in this problem anywhere? So you can't do whatever you want, because we keep talking about the fact that we can do whatever we want as long as we do it to both sides. There's no other side to do that to. That's why I can't just divide by 3, because I don't have anything else to divide by 3. If I'm going to do that, I have to do it twice. I have to keep things balanced. But that doesn't stop me, because there's no equal sign, that doesn't stop me from manipulating it and writing it differently so that it's equivalent. This is still equivalent because 9 is the same thing as 3 squared. Well, this worked out well for us because now notice that my 3 and my 3 are the same. Okay, but what do I do with, we'll get to that. What do I do with this 2 first? I do. I bring that 2 down and I multiply it with the 4. So really this is 8 times the log base 3 of 3. But we know what happens to the log base 3 of 3. It cancels, so I'm really just left with 8. So my answer to this problem is just 8. Okay, so we have 3 problems that we're left with back here. 22 and, or 2 problems, I'm sorry, 22 and 23. What's different about these? Yeah, the log's the exponent. Okay, but are my bases still the same, the way this is written?
Yes.
Yes. So guess what? They still cancel out because this is 12, or sorry, this is 7, and that's 7. That whole log thing still goes away, and I'm just left with 30. And then what's going to be the answer to 23? 1. That was a terrible looking 1. There we go. So you have now learned to fully simplify logs. So those are done. Do you think you can do this to problems like 16? Why not? Yeah, and there's variables left in those problems. So for problems like 16, because they have variables in them, that's not going to work out, okay? But for problems that have numbers in it, we want to see what we can come up with. So look at the front. So let's start with problem 2. So problem 2, how do we get 128? What math did we do? You multiplied. So when you're simplifying this, you multiply 8 times 16, and why is that we multiplied those? Because you were adding the 2 logs together. Yes. So I need to simplify that. Ooh, square root of 2, no, log base 2 of 128. Can I rewrite 128 as 2 to some power? What power? I don't know. You got a calculator, not me. The question is, can I write 128 as 2 to some power? Are you confident in that one?
Yeah.
Okay. So really, this problem is now the log base 2 of 2 to the 7th power. So what does my answer to this problem end up being? 7. How can you check that in the calculator? You can plug the original problem in. You could do 2 to the 7th, that would work, but you can plug the original problem back in. If you go to math, and you go to log base. Okay, so you go to math, and you go down to log base. It's option A. Then you can do the log base 2 of 128, and you get 7. Okay. But I need you to know how to do them by hand. That's why I'm showing you how to do them by hand, because they're not terrible. Just to review, let's talk about why that works. So we have the log base 2 of 128. Using the rule we learned last week, log base 2 of 128. Okay, I want to rewrite that as an exponential problem. I want to rewrite that as an exponential problem. So how do I do that? So remember, the log base b of a equals x is the same thing as b to the x equals a. Those are interchangeable. So how can I rewrite the log base 2 of 128? Yes, 2 to the x power equals 128. So this is essentially the problem that we're solving, is 2 to what power is going to give you 128? Well, you already told me that. You told me it was what?
7.
That's why the answer is 7. So what logs do is they solve these exponential problems. Well, this one wasn't terrible. We could figure this one out. But what if you had the log base 2 of 150? Well, 2 to what power is going to give you 150? Is that a possibility? Is it a whole number? Is it a whole number? 2 to some power is going to give you 150, and that's a whole number? Because what the question was, what if we had the log base 2 of 150? So then rewriting that, that technically means that 2 to some power equals 150. Is that possible? It's not going to be a nice number. So what would you do to figure that out? Yeah. Like, I mean, you could, you know it's going to be, okay, if 2 to the 7th is 128, 2 to the 8th is 256, then it's somewhere, that x is going to be somewhere between 7 and 8. Yeah, do you want to try and do that by hand? No. So that's where logs come in handy, is they do that math for us. And y'all are lucky because y'all get the log base option. That didn't exist on the calculators I had in high school. So I had to use a change of base formula and know how to plug it in the calculator. It sounds way worse than it actually is. I just like to complain about it because I want to remind you how lucky you are. So, okay, problem 4. You can turn what? Okay, you can turn 8 into 2 cubed. So we have log base 2 of 8, which is really the log base 2 of 2 cubed. And hey, conveniently for us, our 2's are the same, so they cancel out, and I'm just left with what? 3. Okay. What about 6? I have the log base 4 of 64. 64 is 4 to the 3rd? Yes.
Oh, shouldn't you just be able to plug in the problem into the log?
Yes, but I just said that I want you to do it by hand. You're welcome to check it in the calculator. I need you to do it by hand.
Yeah.
Okay, so this is really 4 to the 3rd power. So what's our answer going to end up being for this problem? 3. 8. Log base 8 of 32. Can I rewrite 32 as 8 to some power? Okay, I want you to put this in the calculator for me. I know, like I'm telling you, I want you to put it in the calculator because I want you to see what the answer is, and then we're going to figure out how that answer comes from this problem. What is it? It gives you a fraction, or it should give you something you can put into a fraction. Math, enter, please. It's 5 over 3. So this one, log base 4 of 800, you really can't, like, without doing a lot of manipulation and a lot of simplifying, you really can't do a whole lot with that. So we're going to leave it alone. So. Okay. All right, 12. The log base 2 of the square root of 1 over 8. And I know a lot of you guys went ahead and simplified this, and you got the log base 2 of square root of 2 over 2? Square root of 2 over 4.
1 over 2 times the square root of 2?
I don't know. Something with 2 and square root of 2, and I don't. Yeah, it'd be square root of 2 over 4. Okay. Which that's not terrible. And I'm not saying you're wrong when you did that. But I didn't go any further because I knew what we were doing with this. And I need to stop here because this is actually going to be helpful to us if we have it in this format. So tell me what you know about 8. Yes. So really, then I could say this is the log base 2 of the square root of 1 over 2 cubed. That's better. Because at least now, like, I have the same bases, right? Yeah. Okay, but I've got to do some manipulation here because I cannot leave it like this and just, like, cancel out the bases and, like, be left with 3. That's not how this works. Because for several reasons. Number 1, where is this 2 cubed? It's in the denominator and... yeah, so I've got those 2 things that are stopping me from just, like, saying poof, be gone and, like, the answer being 3. So talk to me about square roots. How can we rewrite square roots as exponents? It's to the 1/2 power. It's TIBO, the top and the bottom out. So really, I could say then that this is the log base 2 of, and I'm going to ask a super random question. What's the square root of 1? Okay, so I'm just going to drop that square root part from the numerator because it's still going to give us 1 over 2 to the 3/2 power. Because I can rewrite the square root as 1/2. So there's an understood 2 out here, and that's where this 2 comes from that's in my denominator. Okay, so that took care of the square root part. That's gone. But we said there was something else that was keeping us from just saying poof, be gone. And that was the fact that 2 is in the denominator. So how do I do, what can I do to exponents if I want to move something that's in the denominator to the numerator? Yes, if I change the sign of the exponent, then what I did is I essentially flipped it across the fraction. So if it's in the bottom and I want to move it to the top, then I just make it the log base 2 of 2 to the negative 3/2 power. So now, because these are gone, we can say poof, be gone, and what's our answer going to be? Yes. 14, the log base 4 of 128. Tell me what you know about 128. It is 2 to the 7th. Okay, so I'm going to write this as the log base 4. Okay. Of the square root of 2 to the 7th power. Oh, so you think I should write my base as 2 squared? Okay. So really the log of base 2 squared. And this, then what? Yes, this square root of 2 to the 7th is really 2 to the 7 over 2 power. Okay, so it worked out well because now my bases are the same. So I can say poof, be gone. Why would it be 7 over 4? Okay, so what I have to do mathematically is 7 over 2 over 2. That's really what it is. If you don't believe me, go back and look at problem 8. That's where that 5 over 3 came from. We divided the exponent of the big base by the exponent of the subbase of the log. So 7 over 2 is really 7 over 4. So that's our answer. 16.2 notes and homework. Expand the following logs using the properties of logarithms. So what do you think we're doing with these problems? Yes, we are doing logarithms. What do we do with 16.1? How many logs did you have? 2 or 3, and you combine it into 1, right? We're taking it apart. We're going the opposite direction. So same properties, we're just expanding it back out. So log base 3 of x squared y z cubed. So what's happening with the x squared, the y, and the z cubed? Am I adding, subtracting, multiplying, or dividing? So when I multiply and I separate that out into multiple logs, what am I going to do with those logs? Add them. So really this is the log base 3 of, yep, x squared plus log base 3 of y log base 3 of z cubed. Anything else I can do with that? I can take my exponents and I can move those to what? The front. They can become coefficients. So really, that was a terrible drawing arrow there. So this can become 2 log base 3 of x plus still log base 3 of y. Can't do anything else with that. Plus what? Yes. There was a question in first period, and I thought it was actually not a terrible question. They wanted to know, because I have log base 3 of z to the third, and they're like, well, there's 3's here, and there's a 3 here. Can I just cancel those out and say poof, be gone? I cannot, because where is this 3 up here? It's the exponent, so that doesn't work out. It's okay. It's the exponent, so that doesn't work. It only works if these two things right here are the same. If they're the same, then we can say poof, be gone, and we can end up with just that exponent. But they're not the same, so that's not going to work out. Okay, problem 2. Ooh, what do we have in this problem? Division, so that means we're going to, yeah. What does that ln stand for?
The log of e.
It's the base of e, and it stands for natural log. Yeah, it's not loser, sorry. So it's the ln of what's going to come first? Do what? Can I put that as 1 or do I need to put it as 2? It's however you want to write it. You can go ahead and expand it out as 2. I would. So ln of x, I'm going to write it as 2 because that's ultimately what we're going to do. And then what am I going to do with that y cubed? Add or subtract? Add ln of y cubed. And then ln of z squared. And why was that one subtracted? Yes. Does it matter what order you put them in? No, it's literally based on the sign. Like, so you could have put negative ln z squared first and then put everything else, because all that minus means is that part's in the denominator and the positive means it's in the numerator. Could I make that even more simplified? Could I do something else to it?
Yeah.
What? Yes. So ln of x plus 3 ln of y minus 2 ln of z. So all of this is due on Friday. 16.1 part 1, which you already had, that you just have to finish the odds at this point. 16.1 part 2, which is also known as 16.2, because I labeled them as both. Why, I don't know. I wrote this last year and I didn't realize I did that, so I wrote both names on there. It's the same thing. It's this little assignment that's got 9 problems on it, 12 problems, sorry. And then your bell ringer and your project are all due on Friday. Your project is not due until 11:59 p.m. that night.